Hi guys, so today we'll be solving the sum called meeting the rule 2. It's a famous problem. It has been asked in a lot of companies, so let's solve it. Given an array of meeting time intervals, intervals where intervals of I equal to start I and I, return the minimum number of conference room required. So basically we have a 2D array here and intervals are given where they represent the start time and end time of the interval. So if we try to see here that 0 and 30 is one interval, 5, 10 is the second interval, 15, 20 is the third interval. So we have to find the minimum number of conference rooms required. So for example, if a meeting is happening in the first interval and we need another interval, we have another interval which needs to have a meeting in the same room. So that is not possible, right? So we will be needing two rooms here. And in the third, when we try to see that it is between 15 and 20, so if it also needs it, if it is between any of these intervals, so we'll be requiring the third meeting room. So similarly, in the second example that we see is 7, 10, and 2, 4. So the starting time and the ending time of both the intervals is different. So we don't need a meeting room. Only one meeting room would be fine because the start time and the end time are different. But when we see here 0 and 30, and in the second interval we have 5 and 10. So 5 and 10 is between 0 and 30, and we will be requiring two intervals now, two meeting rooms. And similarly, in the third interval, when we check that 15 and 20, so 0 and 30 and 15 and 20 is between the first interval, is in the first interval, but it is not there in the second interval. So at simultaneously, we will be requiring only two meeting rooms here. So the intuition is quite simple that we'll be checking that if the start time and the end time of any of the intervals is between the interval which we have. If it is there, then we need a room. Otherwise, we don't. We'll just increase the ending time and check if there's a overlapping condition. So I'll code along and it will be more clear. So what we'll do first is that we'll be creating a vector of start time and end time, and we'll simply put all the intervals in that vector. So all the start time would be in the um, start time will be basically uh, m of 0, and end would be equal to, okay, so we'll just push back. We'll push back. Since it's a vector, we'll push back in the vector. So n underscore push back m of 1. Now, since we have put all the start time and end time together, we'll be simply sorting it. Why we are sorting? Just because we need to see if there's a overlapping condition, and sorting will help us to organize the time. Start, end, sort, end dot begin, end dot end. Now we have the two vectors ready, the start time and the end time. Now what we'll be doing is that we'll be creating a two pointer which will be s equal to 0 and equal to 0, and s will be less than equal to start dot size s plus plus. And we'll be checking if the end of E is less than equal to start of S. So At that time, we'll be increasing e. Otherwise, we'll just be uh, we'll have to create a room variable that will store the number of rooms required, room plus plus. So if in the vector the ending time is less than equal to the start time, so at that time we don't need to increase the rooms required, because the ending time is it is not overlapping with the start time, and that's fine. So we'll be just increasing the ending time, and we'll be checking if the next ending time is overlapping with the start time. If it is, then we'll be simply increasing the room variable, and we'll be storing the number of rooms required. And okay, so that's how the algorithm will function. Now we just have to return the room. Oh, there we go. All right, thank you guys. I hope you guys understood the problem. Thank you.